On July 1st, 2025, astronomers at the Atlas telescope in Chile spotted something extraordinary that would challenge everything we thought we knew about interstellar visitors. This is 3I Atlas, the third confirmed interstellar object to visit our solar system. And it absolutely shouldn't exist, at least not according to what we understand about the cosmos. An interstellar object is defined by its trajectory. Unlike comets born in our solar system that orbit the sun in elliptical paths, interstellar objects follow hyperbolic trajectories, traveling so fast that the sun's gravity can't capture them. And 3I Atlas has an orbital eccentricity of 6.139, extraordinarily high compared to the 1.2 of Oumuamua or the 3.4 of 2I Borisov. It passed closest to the sun on the 29th of October 2025, coming within 1.36 astronomical units at an incredible 68 kilometers per second. But here's where things get truly strange. When astronomers began analyzing it, they discovered it's massive, with a nucleus diameter estimated at 5 to 6 kilometers across, roughly the width of Manhattan Island, with a mass of approximately 33 billion tons, making it roughly 1,000 to 1 million times more massive than the two previous interstellar objects we've detected. This creates what Harvard astronomer Avi Loeb calls a major anomaly, because based on our models of planetary system formation, we should have detected somewhere between 100,000 to 1 million interstellar objects the size of Oumuamua before ever spotting something as massive as 3I Atlas. Yet we've only found two previous interstellar visitors before this giant showed up. It's like fishing in the ocean for the first time and immediately catching a whale after only catching two minnows. The strangeness doesn't stop with size, because when scientists pointed instruments like the James Webb Space Telescope at 3I Atlas, they found its chemical composition to be deeply unusual. The gas cloud surrounding it contains only about 4% water, by mass instead dominated by carbon dioxide, with a CO2 to water ratio of approximately 8 to 1, one of the highest ratios ever measured in any comet. But the really weird part is that spectroscopic analysis revealed the gas around 3I Atlas contains much more nickel than iron, the opposite of what we see in normal cosmic abundances, and the ratio of nickel to cyanide in its coma is orders of magnitude higher than any of the thousands of comets we've studied, raising eyebrows because it resembles processed materials more than natural cosmic dust. Perhaps the most visually striking anomaly is its bizarre jetting behavior. When the Hubble Space Telescope captured detailed images in July and November, it revealed the comet has jets pointing in multiple directions, including directly toward the sun, and this anti-tail or sunward jet appeared as a narrow, elongated feature extending millions of kilometers. High-resolution images from multiple angles, including observations from the HiRISE camera on the Mars Reconnaissance Orbiter, confirm this is not a geometric illusion, but genuine ejection of material directly toward the sun. And even more peculiar, the jets appear to be tightly collimated, maintaining narrow, well-defined streams rather than diffusing into space as you'd expect from simple gas release, with some observations showing bidirectional jets emerging from opposite sides of the nucleus, in a pattern that looks almost artificial in its symmetry. Now we come to perhaps the most controversial anomaly of all. After analyzing its trajectory using data from NASA's JPL Horizon system, astronomers calculated that on the 16th of March 2026, the comet will pass within 53.445 million kilometers of Jupiter, and this distance is essentially identical to Jupiter's Hill radius of 53.502 million kilometers, the region where Jupiter's gravity dominates and where the Lagrange points sit, making it ideal for placing satellites with minimal fuel requirements. The probability of an interstellar object randomly arriving at exactly this distance from Jupiter is approximately 0.004%, or 1 inch 25,000, and this precise encounter was made possible by non-gravitational acceleration that 3I Atlas displayed near perihelion, meaning something pushed or altered the comet's trajectory in just the right way to line up this encounter with mathematical precision. As 3I Atlas approached the sun, astronomers noticed it brightened faster than any comet on record, and its color became bluer than the sun itself. Between early July and late October, its brightness increased at a rate that would require either a much larger surface area than estimated, or an internal energy source supplementing solar heating, and the blue color suggests different chemistry than typical reddish comets, with some speculating it could indicate temperatures higher than those produced by solar heating alone. Recently, scientists achieved another first when the X-ray imaging and spectroscopy mission captured the first X-ray detection of any interstellar object, observing 3I Atlas as it passed through the inner solar system, confirming significant ongoing outgassing and giving scientists a new tool for analyzing the comet's structure and chemistry. The astronomical community is deeply divided over 3I Atlas. Researchers like Avi Loeb argue that the combined anomalies suggest a probability so low that extraordinary explanations, including artificial origin, deserve serious scientific consideration, having catalogued what he identifies as 13 distinct anomalies that, when combined using standard statistical methods, result in a probability potentially less than 1 in 10 million. On the other side, planetary scientists counter that every single anomaly has possible natural explanations, and that with only 3 interstellar objects ever observed, we have an incredibly limited sample size. So 3I Atlas might simply represent a type of comet we've never seen before. Perhaps one formed in a planetary system very different from our own, and they raise concerns about identifying anomalies after observing an object rather than predicting them beforehand, which risks the Texas sharpshooter fallacy. They also point to Oumuamua, whose unusual characteristics sparked similar speculation about artificial origins. Yet years later, most scientists agree natural explanations adequately explain its behavior, but defenders of investigating the artificial hypothesis argue that dismissing it without proper analysis is itself unscientific. What we can say with certainty is that 3I Atlas has already taught us that interstellar space contains objects far more diverse than we imagined. Whether natural or artificial, it demonstrates that our catalog of cosmic phenomena remains woefully incomplete, and the debate itself is valuable because it pushes us to improve our instruments, refine our models, and question our assumptions. The Vera C. Rubin Observatory promises to detect hundreds or thousands of interstellar objects over the coming years, and each new visitor will help us build a statistical foundation for understanding what's normal, what's rare, and what's genuinely anomalous. Perhaps most importantly, 3I Atlas reminds us to stay humble because just 2 centuries ago we didn't even know other galaxies existed. A century ago we thought the universe was static and eternal, and 50 years ago we didn't know about exoplanets. So every generation of astronomers has had to revise fundamental assumptions about the cosmos. Maybe 3I Atlas is just a weird comet. Maybe it represents a completely new class of interstellar object formed under exotic conditions we haven't yet imagined. Or maybe, just maybe, it will turn out to be the first confirmed detection of extraterrestrial technology, the answer to the question that has haunted humanity since we first looked up at the stars: are we alone? Whatever the answer, 3I Atlas has earned its place in astronomical history because this object shouldn't exist according to our current understanding. But it does, and that means there's still so much more to learn, because the universe, it seems, still has secrets to reveal, and the best scientific discoveries often begin with 3 simple words. That's weird, isn't it? 3I Atlas is definitely weird, and where it leads us is the adventure we're all on together.